This is lesson 7 of Unit 1. We're going to continue on our theme of rational numbers, which is what we've been working on for the last 2 lessons. And since we've already looked at what a rational number is and how to work with rational numbers in a variety of operations and how to apply BEDMAS to rational numbers, now we're going to go one step more complex and we're going to add in powers of rational numbers. Now, just to refresh, a power is a base raised to an exponent. So say we have 2 to the exponent 3. 2 is the base. So this would be called a power of 2. 3 is, of course, the exponent. Now remember, an exponent tells you how many times to multiply something by itself. And this whole thing is called a power. So now instead of using a whole number base like 2, we're going to look at what happens when the base is a rational number. Okay, so we have 3 different rules that we're going to look at today, and each of them are applied in a very similar manner. The only difference between the rules is a negative sign. And where the negative sign is determines which rules we're going to be using. So that's the thing you have to be really careful of. Other than the negatives, everything is going to work just the same way in all 3 rules. Now, what you need to remember with taking the power of a rational number is the exponent is applied to everything inside the brackets. So in this first example, the exponent is applied to both the numerator and the denominator. So I'm going to put that over here. Okay. The exponent always applies to everything, I'm putting that in caps because it's important, everything inside the brackets. Okay, so let's look at that example. 2 over 3 is our rational number. So the numerator is 2, the denominator is 3, and what you're going to end up is 2 to the exponent 2 over 3 to the exponent 2. You see I've applied the 2 to the numerator and the 2 to the denominator. 2 to the exponent 2 is 4. 3 to the exponent 2 is 9. So your final answer there is 4 over 9. Now that cannot be reduced in any way, so 4 over 9 is the final answer. And that goes for all of your rational numbers, your fractions, that have no negatives. You always apply the exponent to the top of your fraction and to the bottom of your fraction the same way. So now we throw in the first wrinkle. We're going to look at what happens when you put a negative in front of the brackets. What happens when that negative's in front of the brackets? So we're looking here at rule number 2. The negative is not actually in the bracket, okay? It's outside the bracket. It's outside the bracket. So, does the exponent apply to the negative? And the answer is no, because the exponent applies to whatever's inside the brackets that it's touching. So this exponent is next to, okay, if I put that dot of highlight on it, it's touching that brackets, and so that means it applies to whatever's inside the brackets as per the rules of BEDMAS. Brackets come first. The exponent then applies to everything inside the bracket, and the negative is not inside the bracket. So we're going to treat this exactly like we treated the first one. We're going to say that 2 applies to both the numerator and to the denominator. Okay? And that negative is just going to stay there. It just stays there. I put that in. It's not changed by the exponent at all. So it's going to be like that. Okay. And then, so we get the negative 4 over 9. So because the negative was outside of the bracket, it's not affected. So now we get to rule number 3. And rule number 3 looks really complicated. And the reality is that it isn't. If you really understand what the rule is telling you and how these exponents work, the rule is just a quick way of doing what should be obvious anyway. So let's think about this. When the negative is inside the bracket, it is affected by the exponent. So if the exponent is a even number, even numbers 2, 4, 6, 8, 10, 12, 14, 16, etc., 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 if it's an even number, you're going to lose the negative. Okay, so let's just quick take an example here of negative 2 squared. That's negative 2 times negative 2. Because that's what the squaring tells us to multiply the base twice. So negative 2 times negative 2. What happens when you multiply a negative by a negative? Right, it becomes a positive. So the answer is positive 4. What happens if we have that same negative 2 and we take it to a power of 3? Take it to an exponent of 3. So we've got negative 2 to the exponent 3 becomes negative 2 times negative 2 times negative 2. I'm multiplying it 3 times because that's what my exponent tells me to do. I multiply a negative times a negative, I get a positive. I multiply that positive by a negative, and the answer becomes negative again. So the whole answer is negative, and then 2 times 2 times 2 is actually 8. So the answer is negative 8. And that's how that works with integers. And that is something that you should have been familiar with in your previous studies. So now we're going to take this idea that whether or not the exponent is even or odd really does make a difference. We're going to take that idea and we're going to apply it to these rational numbers, to our numerators and denominators. And it's not going to get that much more complicated. Because when you're stuck, if you can't remember the rules, you can always go back to what I call the first principles or the basics and figure it out on your own, relying on how well you understand what an exponent tells you to do. So let's look at our first example. Okay, negative 5 over 6, all to the exponent 2, and the negative is inside the brackets. So if I write this in expanded form, I'm getting negative 5 squared over 6 squared, right? Because I've applied the exponent to both the numerator and the denominator. Okay. So we could say this is negative 5 times negative 5 over 6 times 6, which gives us 25 over 36. Which if you see this rule here, if I'm going to take a shortcut, that negative 5 over 6, I know because the exponent's even, that it just makes it positive anyway. So I say, okay, 5 squared is 25, 6 squared is 36, and I get my answer. So the rule is a shortcut. And it's a shortcut that's been derived from a knowledge of how exponents actually work. So you can go the long way or the short way. They're both correct. Okay? So let's take another look. We've got the same rational number, negative 5 over 6, and we have it raised to the exponent of 3. Odd or even? It's odd. Let's look at the rule here. Okay, so if we have a negative within the brackets raised to an odd exponent, then it just becomes negative and we treat the rational number like we would anyway. So the whole answer is going to be negative. So now, I'm not sure if you've ever seen this notation before. Okay, this kind of notation before. So what it's saying is A and B are integers, and n is an even number. Or if you look at the rule below it, a and b are integers, which means they're whole numbers including negative numbers. And n in this case is from the positive odd numbers, 1, 3, 5, 7, 9, 37, 83. They're all odd numbers. Okay, so let's solve this one here. The answer is going to be negative 5/6 raised to the power of 3. So 5 to the power of 3 is 125. 36 to the power of 3 is 216, and the whole answer is negative because it's odd. Okay. So let's take one look at this thinking question I've hidden at the bottom of your note. Pikachu thinks that negative 1/2 to the exponent 4 is smaller than negative 1/2 to the exponent 3. And Pikachu is wrong. Now, if we didn't have the negatives, Pikachu would be right, because with this kind of thing, the 4 applies to the 1 and the 2. As you see these proper fractions, where the numerator is smaller than the denominator, as you see them going to larger and larger exponents, they're actually going to represent smaller and smaller and smaller fractions. This is going to be 1/16. 2 to the exponent 4 is 16. Okay? Whereas 1/2 all to the exponent 3 is going to give you 1/8. And 1/8 is larger than 1/16. I think we're taking one whole thing and cutting it into 8 pieces. Those pieces are going to be larger than if we cut it into 16 pieces. Each piece is going to be smaller if there's 16 of them. So 1/8 is larger. But it's the negatives. The negatives are what make this different, because negative 1/2 to the exponent 4 is positive 1/16, right? Because it's a negative, but it's raised to an even exponent. So it's going to be negative 1/2 times negative 1/2 becomes positive, times negative 1/2 becomes negative, times negative 1/2, 4 of them. Now we have a positive answer. But this negative 1/2 to the exponent 3, because that exponent's odd, the answer stays negative. So you get negative 1/8. Negative 1/8 is smaller than positive 1/16, and Pikachu is wrong. So always be very aware of where your negatives are. If the negative is outside the bracket, your answer is always negative. If it's inside the bracket, it depends on your exponents.